So let's talk about the four main proprioceptors we care about and how they relate to muscle activation. So if we look at this quad chart, you'll notice that on the x-axis, I have muscle activation. And a proprioceptor can either increase your muscle activation or it can decrease your muscle activation. So it's either going to be increasing the tone of the muscle or the contraction, or it's going to be causing it to relax when those proprioceptors are activated. The other part of the quad chart is going to be the threshold. And we can have high threshold or low threshold proprioceptors. And what we mean by high threshold is we mean that it takes a strong stimulus or a strong amount of a stressor for it to actually activate and do its job. So it's sitting here, it's pretty calm, it's pretty relaxed. You start messing with it, nothing really going on. You start messing with it a little bit, nothing really going on. But when you really start antagonizing it, when you really start pissing it off, at a certain point, it's gonna just snap, and when it snaps, it's gonna make a big change. It's gonna make a big stink, right? So it's that think about a person who's really kind of calm and relaxed, and they're just chilling, but if you do enough to make that person angry, that's gonna cause them to kind of explode, and you get the volcano reaction. That would be like a high threshold fiber. A low threshold fiber, on the other hand, it's not gonna take a lot for it to say something. So if there's even the smallest annoyance, it's gonna respond, it's gonna react. But its reaction is gonna be small as well. So instead of a big change, if we're talking muscle activation, maybe it causes it to change by a couple percent. So if it was at 5%, you activate these, maybe it goes to like 6 or 7%, or it goes down to 3 or 4%. So it's gonna take a very small amount to change it, but it's also going to only cause small, subtle changes back and forth. So high thresholds respond to high stimuluses and they cause a big change. Low thresholds respond to those low, everyday stimuluses and they cause a very small or subtle change. Now, let's get into the specifics. So first we're gonna talk about our high threshold fibers. And we have muscle spindles and we have Golgi tendon organs or GTOs. Now, what a muscle spindle does is it is actually located inside of the muscle itself. And what it responds to is as the muscle gets stretched, as the muscle elongates, at a certain point, it's going to send a signal to your nervous system to let it know that it's being stretched too far or it's getting dangerously elongated. And so you're stretching a muscle, at a certain point, if you stretch it too far, it's gonna be at high risk for tearing. And so what it's gonna do is it's gonna send a signal to the brain so that the brain knows that it's getting to a dangerous level. Well, in response to that brain signal, it's gonna get what we call your stretch reflex. And what a stretch reflex is when you can pull a muscle far enough away, and it actually is not just the length of it, but it's also how quickly you do it. So if you do a big stretch and you do it very quickly, that muscle sends a signal to your brain, and your brain causes that muscle to contract harder and pull the ends itself, right? So if I had someone pulling me apart, right, and I wanted to not have my arms rip out of my sockets, I could contract my arms, I could pull them back in so that I'm not stretching as far. That's how a muscle spindle works. So in response to largest amounts of stretching of that muscle, as well as very quick stretches, it activates, it's gonna cause that shortening, it increases or it spikes the muscle activation level. Now, a GTO or a Golgi tendon organ is gonna be located in the tendon itself. And we need to remember a couple things about tendons. So first, a tendon connects, let's say, a bone, or this is gonna be my bone structure, to a muscle. So on the other hand, we have a bone over here and we have a muscle on this side. And so as the muscle contracts, it's gonna be pulling that tendon, and it's gonna be elongating the tendon. Well, another thing we need to know about tendons is that they're connective tissue. And think of connective tissue kind of like taffy. So it's gonna stretch, but it cannot contract. So when we stretch our muscle too far, its response so that it didn't tear and it didn't rip in half or get damaged was to contract and actually fight that stretch, Well, a tendon is gonna get stretched, but it can't contract to actually cause that to happen. So when a GTO gets activated, or when that tendon has so much tension on it that it's potentially gonna tear, it's potentially going to rupture, what it does is it sends a signal to the brain, and instead of it getting a greater contraction, it tells the muscle that it's attached to relax and calm down and to chill out. It's gonna decrease that muscle activation in the muscle that's pulling it too far. So some muscle's pulling me all the way over here, it's getting too extreme. I tell the brain, hey, you better make that muscle relax, otherwise I'm gonna get damaged. The brain shuts down that muscle and now I'm relaxed. That's how a GTO works. So a muscle spindle and GTO, they're opposites. Muscle spindle, increase in that activation level, it's gonna spike it, you're gonna get a greater contraction. A GTO, if it's activated, is gonna cause the muscle to shut down. Now, we also have Pacinian fibers and Ruffini endings. And Pacinian fibers, an easy way of thinking about these, or an easy way of understanding how they work, is think about going on a long road trip. So if you've ever been in the car for 3 or 4 hours and you get out of the car, how do your muscles feel? They probably feel a little bit of tension, right? You have maybe a tense neck, they feel a little stiff, you want to get out of the car, you want to move your legs, right? You want to try to increase your range of motion. The reason why you see that increased tension is because Pacinian fibers, they respond to vibration, low levels of vibration. So when you're driving in your car, you might not think about it, but your car has subtle vibrations happening constantly. And so if your body was totally relaxed when you're riding in a car, you would be moving all over the place, your organs inside would be shifting a lot, and that would cause a potential issue. And so what your body does in response to these low levels of vibration, which cause movement in your body, is it makes you more rigid, it makes you more stiff, so that instead of all your body moving separately, it kind of has like a relaxed part here, it makes you one unit so the whole thing shifts, but it doesn't shift as much. So Pacinian fibers, in response to low levels of vibration, will change the muscle tone a little bit. So maybe instead of being at 5%, I'm riding in the car, my muscles become a little bit stiffer, now I'm at about 10%, right? So it's a subtle difference and it's a subtle change. Ruffini endings, or the last one we're going to talk about, they respond to pressure. And if you've ever gotten a massage before, you know that a good massage, if it's done correctly, will actually make your muscles relax. And the reason why is because these Ruffini endings, which are in your body, in those muscles and in the connective tissue that surrounds those muscles, in your fascia, when they have the correct amount of pressure placed on them and you hold that pressure for a decent amount of time, it causes the muscle to relax. And so your Ruffini endings decrease the muscle activation in response to a low stimulus, right? So it's not a really intense pressure. It's not like you're just taking one finger and just jabbing in and then all of a sudden your arm relaxes. It's a constant pressure that actually causes that change in tone. And so that's how massage works. So now that we understand these proprioceptors, we can understand that if we want to increase the activation of the tone of the muscle, we're going to need to activate our muscle spindles and our Pacinian fibers. And we could use different strategies or techniques to increase that activation. On the other hand, if we wanted to decrease muscle tone and we wanted to increase our range of motion, we could potentially activate this GTO and or our Ruffini endings. And so those are going to come into play, and we're going to talk about them in this next series of videos, is how these relate to our actual type of stretches.